Okay, so for this video, I'm going to discuss a partial question with all of you, which I think it is quite challenging. All right, so this paper I take out from June 2017, paper 33, question 11b. Okay, it is about a complex number. Then we learn all the concept before actually. You can use the old concept that we learned before also. But I think this question can be very easy if you have uh, further information about a concept that we learned before. All right, so I think I will split this question into two parts. The first part is I'm going to use a very traditional way to solve this question, but the method is quite long. And the next video, I'm going to discuss and introduce further information that about a concept that we learned before. Then we'll use that concept to solve, and it will make the solution become much more shorter. Right, so I will use the traditional method first for this video. Right, okay, so you can have a look for the question. So in this question, they tell you that I have complex number u and v. Okay, and then u, they give you this as the complex number 1 plus 2 square root 3i, and then v is 3 plus 2i. Okay, so in an Argand diagram, U and V are represented by the point A and B. So you can see that I try to sketch it out by using a proper ratio. All right, so I measure it by using the ruler, the ratio that I use, and then I try to sketch out or plot the points. So you can see that the A here will be the point U, okay, the complex number U. The B here will be the complex number V. So I plot it out clearly. Then here they tell you that a third point C lies on in the first quadrant. All right, so this is one of the important information. So C is in the first quadrant, and it is such that BC equals to 2AB. So that means the length of BC equals to the length of AB. Second important information. And another extra information is they tell you that the angle ABC is equals to 90 degrees. All right, so they give you actually three important information about the point C. So they want you to find out the point C, complex number Z represented by point C, given your answer in the form of x plus iy, and x and y are real and exact. So highlight the word exact. That means they don't want to have any decimal number in your x or y. Okay, they want the exact value. Okay, so before you can start answering this question, right, there are three important information here. First, you know that the length of BC should be equals to 2AB. And the second thing is angle of ABC equals to 90 degree. So when I try to sketch an Argand diagram, I want to know where is my C. Okay, so I conclude that my C is here. So when I measure, right, I will try to imagine, okay, the length of AB is equals to 2BC. So that means this length should be 2 times of this length. Okay, and then they are 90 degrees to each other. So maybe some student will tell me, hey, actually the C can be at other places also, because C can be here also. Okay, so the AB length equals to 2 times, BC length equals to 2 times of AB, and then they are also 90 degrees here. But if you have a C in this part, generally you will see that the C is actually not in the first quadrant. Right, so that's why they restricted everything for you already. Okay, so in short, when I try to analyze this question, I know that my C should be around here. All right, okay, so first, to solve this question, to find out the C, you can use a very traditional way. That means you can use coordinate geometry to solve it. All right, so how to use coordinate geometry? Okay, so I will start from the information that they give me. Okay, so let's say I'm having BC, the length of BC is equals to the length of AB, 2AB. Okay, so I let C as point xy because I don't know what is the value, right? So I let C equals to point xy. So to get the BC, the length of BC means, what is it? So you learned it before, right? The formula x minus the point B, x minus 3 square plus y minus 2 square. And it is equals to 2 times of AB. So what is the distance for AB here? The distance for AB here, maybe what I will use is I will use 3 minus 1 square, okay, x minus x square plus y minus y square. So 2 minus 2 square root 3 square. Okay, then after that, what can I do now is I will square both sides. So when I square both sides, I will have x minus 3 square plus y minus 2 square, and it is equals to 4 times of 4 plus 2 minus 2 square root 3 square. Okay, so 3 minus 1 is 2, right? So I square it become 4. Okay, then when I square the whole thing, this is what I have here lah. Right, so I will make this as the first equation, because you know when they give you more than one information, right, you might need to solve simultaneous equation to get the answer for x and y. So I will make this as first equation. Okay, so for me, I don't really want to expand everything yet because I believe that if I expand everything, right, it will become much more complicated. So I will just keep it in this way first. All right, so this is my first equation that I get. All right, so second equation. So second equation, I might use it like this for this part. Okay, so since they tell me that the angle ABC is equals to 90 degree, which means the gradient of AB multiply with the gradient of BC, because they are 90 degree to each other, right? So should be equals to -1. So what is the formula for gradient? Okay, so the formula for gradient, what can you have is you can have y2 minus y1. So y2 minus y1 means 2 minus 2 square root 3 divided by 3 minus 1 multiply with the gradient of BC. You can use y minus 2 divided by x minus 3, and it is equals to -1. Okay, then I try to keep the y minus 2 on the left hand side only. So when I bring it up, everything, I will have so I will have negative x minus 3, then I will have 2 over 2 minus 2 square root 3. Okay, and after that, I will make this as the second equation. Again, I will not want to like expand everything to make the equation looks a bit more complicated. I never tried, but I believe that if I expand everything, it will become a bit more complicated. So I will just leave it like this. Okay, so I have equation number 1 and also equation number 2 already, right? Okay, so I hope that you can see that. Okay, so now let us try to solve the equation simultaneously. All right, so to solve the equation simultaneously, what am I going to do is I will sub equation number 2 into equation number 1. So that means I will substitute this y equals to 2, right? This whole equation into this part. Okay, so I will start here. Okay, so the steps now will be a bit more complicated already. So we have to try slowly. Okay, so substitute 2 into 1. Okay, so what do you have when you sub 2 into 1? So you're having x minus 3 square plus y minus 2 is negative x minus 3, then 2 over 2 minus 2 square root 3, then the whole thing you want to square it, equals to 4, then 4 plus 2 minus 2 square root 3 square. Okay, so I believe that this is not hard for you to understand, and you just substitute it. Okay, then I just copy the x minus 3 square first, then plus. Okay, if you look at this one, negative, the negative here, so negative when you square it become positive, so the negative disappear. All right, then the whole thing also you need to square, it will become x minus 3 square, then 2 divided by 2 minus 2 square root 3 square equals to 4, and then 4 plus 2 minus 2 square root 3, and square. Okay, then now your aim is to get the answer for x. So I'm having x minus 3 square here, x minus 3 square here. What am I going to do now is I will try to factorize out the x minus 3 square. So factorize out this one, I'm having 1. Then this one I will just substitute the 2, the square inside, so become 2 square is a 4. Then I'm having 2 minus 2 square root 3, then square, equals to 4. 4 plus 2 minus 2 square root 3 square. Okay, then now I want to keep the x minus 3 on the left. Then this bracket to the right. But before I can change it to the right hand side, I want to make it in as a one fraction first. So I'm having 2 minus 2 square root 3 square plus 4 equals to what we have on the right hand side. Okay, right, so now x minus 3 square on the left. Then all the other thing on the right. So when I move all the other thing, so this is the original right hand side one. Okay, so this bracket, this fraction, when I bring it over, the denominator will become numerator. Then divided by the original numerator here will become a denominator. Okay, so you can see that all my x is on the left already. Then if you try to have a look for what we have here, generally you will realize that this bracket, this whole thing, and this whole thing are the same. So you can simplify that. Which means after you simplify them, you have only x minus 3 square equals to 4. Then 2 minus 2 square root 3 square. Okay, so the 4 here, I can actually make it become 2 square. So everything is having a square now. Alright, so when you want to make all the square disappear, you can take square root both sides. When you take square root both sides, actually you are having the modulus. Okay, like when you are having x squared equals to 2 square, you can write it as modulus x equals to 2. Okay, or x equals to plus minus 2 lah, up to you. You can put a plus minus sign, or you can just write modulus x equals to 2. Alright, so for me, I'm writing it like this. So modulus x minus 3 equals to 2 multiplied with 2 minus 2 square root 3. Okay, and then x minus 3 modulus equals to 4 minus 4 square root 3. And I want to expand this modulus. So when I want to expand this modulus, right, I'm having x minus 3 equals to 4 minus 4 square root 3. Another expansion will be x minus 3 equals to negative 4 minus 4 square root 3. Okay, so eventually I'm having x equals to 7 minus 4 square root 3. Then x equals to negative 4 plus 4 square root 3 plus 3. So for this x, it will be 4 square root 3 minus 1. Alright, so you're having two value for x. Okay, so you can have a try. You can try to press calculator and see what is the value of x that you get here. Okay, you can try to press and have a look. So you will realize that actually both are positive. So both are positive means that, okay lah, so far from here you can still know that it can be either quadrant number 1 or quadrant number 4 when your x both are positive. So no other choice, you have to continue to find out the y. Okay, so from here, okay, so I'm having two values of x. This is one of the value. This is another one. Okay, then I want to find the y. How can I find out the y here? you can refer back to one of the equation that you have just now. You can use back this value to find your y. Okay, so I will write out here, continue from here. When your x is equals to, you are having 2x, right? One of them is 7 minus 4 square root 3. Okay, so 7 minus 4 square root 3. If I want to substitute it into equation number 2, then you're having y minus 2 is equals to negative 7 minus 4 square root 3 minus 3. This is the x, right? X minus 3. Okay, then multiply with 2 divided by 2 minus 2 square root 3. What you need to do here is you just need to be very, very careful. All right, so 7 minus 3, you get a 4. Minus 4 square root 3. Okay, then I'm having 2 minus this. Okay, then from here, you can factorize out the 2. But of course, all this you can use calculator to help you if you're having the ES calculator. Okay, then again, you will see that the 2 minus 2 square root 3 and 2 minus 2 square root 3 can be cancelled off. Therefore, your y here is negative 4. Okay, so can this be your final answer or not? This definitely will not be your final answer. Ignore this answer. Why? Because if you look at the value of x and y, right, it is not in the first quadrant. So they already tell you that your x and y must be all positive. Okay, not in the first quadrant. So your x and y must be positive so that it is in the first quadrant. So very obvious this is not in the first quadrant, therefore this is not an answer. Okay, then now you have to substitute the second value of x. So the second value of x will be 4 square root 3 minus 1. Okay, so x equals to 4 square root 3 minus 1. So substitute into the second equation also. Okay, so I'm having 4 square root 3 minus 1 minus 3. Okay, then 2 divided by 2 minus 2 square root 3. Okay, so for this question itself, sorry, I make a mistake just now also. For this negative 4, it is y minus 2, right? Okay, but y eventually it is still negative 2. So we still ignore the answer because from y equals to negative 2, it also tells you that it is not in the first quadrant. Sorry for that, okay? Then now, if I continue for this part, then I'm having negative 4 square root 3 minus 4. Then 2 over 2 minus 2 square root 3. Okay, then you can take out the 2, then 2. Okay, so maybe for me, I want to factorize out negative 2. When I factorize out negative 2 from here, then I'm having positive 2. Okay, again, I factorize out negative 2 from this bracket. So if I factorize out negative 2, this one will become 2 already. Then 2 minus 2 square root 3. Then 2 over 2 minus 2 square root 3. Then again, from this part, you can see that I can simplify this. Okay, then what do I have next? So you will see that your y minus 2 is equals to 4. And your y is equals to 6. Okay, so I think very obvious already. This value of x and this value of y tells you that your answer is actually in the first quadrant. So your final answer will be 4 square root 3 minus 1. This is the x plus yi. Okay, so this is your complex number for point C. Okay, so this is the question that we are using the coordinate geometry method to solve it. Alright, because according to the information that they give us, we can form two equations from the information and we try to solve it. So the bad thing for this one is it is not hard to understand, but the problem is you will see that the methods, the steps are quite complicated. Actually, it is not very hard also, just that you need to be very patient to solve every single steps here and then try to simplify everything. And for some students habit, right, when they get the equation, they tend to expand everything, so it will make the solution it become even more complicated. All right, so that's the part, that's the bad side about this method. It is very easy to understand. Then if you didn't expand it, it is not hard for you to simplify also, just that you, if you look at the step, it will be a bit more tedious. Okay, all right, so I hope that you have the idea about this method. Then in the next video, I'm going to introduce another concept that we learned before, and how are we going to apply that concept in this question, and the method actually become much more shorter, right? So I will discuss this, I will continue this in the next video.